Hi, everyone. Happy almost Friday. So today we're going to be talking about the aquatic biomes. So for some of you who have aquatic biomes, this might be some useful information. I am so excited for tomorrow to play Chris Harrison. Wahaha. Yeah, I'm excited. So let's talk about aquatic biomes. So water makes up a lot of our Earth. A majority of that water is the ocean. 97.5% is salt water or ocean water. 2.5% is fresh water. And of that 2.5%, 79% of that 2.5% is in ice caps and glaciers. 20% is going to be in groundwater. And just a mere 1% is going to be surface fresh water. So remember, we get most of our water from the ground or from surface water, lakes, rivers, streams. So we really only have a very small amount of water actually available to drink. This is a distribution map of the different aquatic biomes. So you can see all the different lakes. There are a bunch of large lakes throughout the world. These right here in North America, those are the Great Lakes. Lake Erie is pretty close, and Lake Ontario are both pretty close to the state of New York. We also have some large lakes over here in Europe, some large lakes in sub-Saharan Africa. Coral reefs. So these are going to be part of the ocean, but you can see that the coral reefs are really from the equator to 30 degrees north and 30 degrees south. And this is because coral reefs require warmer ocean temperatures. And then all that blue is the oceanic pelagic zone. So we'll talk about the different zones in a bit. And then you have the abyssal zone. That's like deep, the abyssal zone. You also have these things called estuaries. You can also see the large rivers are in green. You have estuaries. We'll talk about what those are in a second. And intertidal zones. So that's going to be around the coast. All right, so rivers and streams, lakes and ponds. So rivers, streams, here's an example of the Mississippi River. Because it's flowing, it's going to have different things that can live in it. Lakes. So again, these are the Great Lakes. Really big, see them from space, but there are a bunch of small lakes and ponds throughout as well that are freshwater. For marine, we have marshland. Oh man, I didn't put a picture of marshland. Marshland is where ocean water kind of mixes with fresh water, and it's marshy, which means it's kind of like swampy. So this is basically like a swamp, but with ocean water. Coral reefs, obviously, that's going to be characterized by like bright, vibrant coral communities. Here's an example of the open ocean. Just kind of what it sounds like, just the ocean. And then estuaries. So this is where rivers meet the ocean. So living in New York, we live on an estuary. The Hudson River meets the Atlantic Ocean here. And around estuaries, you will always get this characteristic like sediment that's kind of like spilling out the mouth of the river. And here it's an interesting area because it's part freshwater and part saltwater. Speaking of saltwater, so one of the things that's going to affect a marine biome is salinity and what can live there. So it's measured in ppt, parts per thousand. Various marine environments have different salinity levels. So obviously, if it's freshwater, there should be no salt in it, or almost no salt. If we're talking about estuaries or marshland, that's going to be brackish water, which is characterized around 30 ppts of salt, a little under 30, which means that there is some salt, but it's not as not as salty as the ocean. And then saline water or salt water, that's going to be in the ocean. The average ocean water is 34.7. And then there's this thing called brine, and that's above 50 parts per thousand ppt. brine is really crazy. So brine is actually more dense than normal salt water. So brine can actually sink to the bottom of the ocean and form brine lakes in the ocean. So there's lakes in the ocean. And there's so much salt that if any living thing goes into the brine lake, it could die. There are some living things that are adapted to live on like the edges of the brine lake. There's some cool stuff on Netflix about this. If you watch like the Deep Ocean episode of, I think, Blue Planet, crazy stuff. It shows a brine lake in the ocean again. So it's brine water with normal water on top of it, but it actually forms a lake in the ocean. Really cool. You guys should check it out. All right, acidity. So this is the pH scale. So 7 is neutral. Most of our drinking water is going to be around a 7. 7 should be pretty neutral. Remember, 0 through 6 is considered acidic. Anything above a 7, about 8 to a 14, that is basic. Remember, acidity is a measure of hydrogen atoms. I'm trying to think if there's anything else. And it's going to change based on location and also human impacts. So we talked about this with the carbon cycle. Carbon dioxide is acidic. And since more carbon dioxide is entering our oceans, our rivers, our lakes, the acidity is decreasing, or the pH is decreasing. So it's becoming more acidic. Dissolved oxygen, or DO. And it's a measure of how much oxygen is in the water. More O2 equals more life that the aquatic biome can support. So remember, all living things go through cellular respiration. So here's cellular respiration right here with the mitochondria. All living things go through cellular respiration, even fish. So fish need oxygen too. All aquatic life needs oxygen. So if there's more oxygen in the water, then more living things can be supported. If there's less oxygen, then things are going to start dying. We talked about this also with the carbon cycle. If there's warm water, there's going to be less dissolved gases, in this case, dissolved oxygen, in warmer water. And this is because of kinetic energy. So if we take a look at this graph over here, we have amount of dissolved oxygen and temperature. And you see as temperature increases, the amount of dissolved oxygen decreases. So again, because of kinetic energy. So a good way to think about it is the warmer the water gets, the more those water molecules are going to move. The more they're moving, the more they're just going to start bumping into the oxygen, the gas, and kicking it out. So the warmer the water is, the less dissolved oxygen and other gases, not just oxygen, and other gases as well. And it all has to do with kinetic energy. Nutrient availability. This is going to be phosphorus and nitrogen. Typically, when we talk about this, we're going to talk about nitrates and phosphates. That's what plants can use, nitrates and phosphates. These are often limiting factors, which means if there's not enough of them, it's going to stop things from growing. Once all the nitrates and phosphates have been used up, there's going to be less things growing. So it's a limiting factor in aquatic ecosystems because it's not super readily available. We talked about this with nitrogen and phosphorus when we talked about those nutrient cycles. We frequently alter this because of our use of fertilizers. Nitrogen and phosphorus are the main components of fertilizer. And when we put fertilizer on our plants in our garden or for farms, it's going to run off when it rains. The rain's going to hit the soil. This water is going to start to move, and it's going to take the nitrates and the phosphates and put them into bodies of water nearby. And this causes eutrophication, which is where the phytoplankton grow abundantly now because there's so many phosphates and nitrates. And then they're going to die. And then decomposers are going to use up all the oxygen to decompose the dead phytoplankton. And it's going to cause all the oxygen to be used up. And then things are going to start dying. Depth. All right, this is pretty simple. How deep is the body of water? So light can penetrate water, but only up to a certain level. So where light can reach is called the photic zone. It's about 200 meters. It varies based on different factors. The aphotic zone is going to be where there's like kind of like the twilight zone you could think of. It's like not pure darkness by any means, but it's dark. And most of our producers aren't going to live in the aphotic zone. The abyssal zone, that's where stuff gets freaky. It is like night in the abyssal zone of the ocean. It's pretty wild. I'm not gonna lie. The abyssal zone is crazy. You should all watch the deep ocean episode of Blue Planet because mind blown. There's some crazy stuff that happens in the abyssal zone. It's like aliens. But yeah, photic zone means it gets sun, which means there can be producers there. Turbidity. So this is the density of suspended particles in a water sample. So you can either use nephelometric turbidity units, which is going to be like a light you shine through, or you could use what's called Secchi depth. I can't say it. Secchi depth, a Secchi disk. So low turbidity means there's like no suspended particles. High turbidity, it's going to look muddy, basically, which means light isn't really easily going to be able to get through. So when you use a Secchi disk, it's like a little disk about this big, and it has a section that's white, a section that's black. You can see it here. When you can't tell the difference between the white and the black, you stop and record the depth. And that's a good measure of turbidity. So obviously, if it has high turbidity, that depth is going to be pretty low. And if it has low turbidity, you can move the Secchi disk all the way down and still, hopefully, if it's clear, be able to see the disk and determine if it's black or white. All right. Interactive notebook time. So you guys should hopefully by now know what you're working on. Maybe. So remember, we are doing bachelor and terrestrial biomes. And just for this moment, I have a song ready. Maybe. No, Beyonce. Okay, well, I had a song ready, and it was a Beyonce song. And now I don't know what's happening. All right, well, that's sad. So remember, you've all been assigned a biome. You need to find your biome using the links. You need to answer all of the questions here. And then on Friday, we are meeting as a class, and we are going to be speed dating. You get bonus points if you dress up like your biome. Don't tell anyone your biome. Don't click on anyone else's name. It ruins the fun. I think that's it. I will talk to you guys in class, and I'm excited for speed dating. Woohoo! Bye, guys.